Welcome to Technical Mentor channel. In this video, we are resuming our previous video series, Filter Design. In this video, we have to write a MATLAB function which implements an FIR filters, FIR filters, with the impulse response in the form value myFIR value HN into. Here we have to design a filter to implement filter design, which name should be myFIR and inputs should be value and HN, where both values, arguments, and return value are scalars, not vectors. So that it could be used in real-time system, you may define this function as, for example, where both outputs input must be scalar and Hn is impulse response of an filter where H is a vector. No high-level MATLAB command filter convolution are allowed. You can test it with moving average filter and make the input with a pulse. Your output should be the impulse response as shown in picture. This is delay shift input Xn input. This is signal Hn impulse response. Okay. Now we see the theoretical work of this task. For implementation, we need an impulse response of Hn and we make a MATLAB function. The figure below is flow diagram ECG signal Xn as shown in figure. The figure flow diagram for implementation in the MATLAB. In this function, Xn is input signal and we pass this input to tabs T, H0, H1, H2. And we got final value Hn. We got Yn as output by summation of Xn and Hn. So we move to MATLAB and see what is the function. So here is our function f and this is my fir input and hn, also this input value hn. Represent fair filter as a global variable. Now we create a loop for the to implement signal. So I is equal to length n. Hn is impulse response minus 1 to minus 1 to 1. Fair filter is equal to I fair filter I and fair filter I input value, and this is also function n length is equal to n minus 1 1 for low from n 1 minus 1 to 1 with step size minus 1. Filter A plus 1 is equal to filter A. A is equal to this in this shift input by one samp to make space. Filter A shift one step and this is one step low is equal to input. Our input is equal to filter A and we have to make one step higher. A plus 1 is equal to filter A. Store new sample into previous space. Okay. Output is equal to, now we have to sum all these results, multiply impulse response, which is equal to yn. This is our function. We will implement this function in the next video. Thank you so much. If you like my video, please subscribe my YouTube channel for further videos.